factors that affect the ionization energy in some way or in other way. So basically there are four factors that affect the ionization energy. So first one factor, we have atomic size, or we can say that the size of an atom. The second factor that is going to affect it is the shielding effect, and the third one factor that is going to affect the ionization energy, it is the electronic configuration, or the configuration, or we can say that electronic configuration, and the fourth one factor is nuclear charge. So these are the four factors that affect the ionization energy, that may cause the increase or the decrease of the ionization energy of an atom, of an element. So the first one factor, how the factors affect the ionization energy. For example, if there is increase or decrease in atomic size, it can also affect the ionization energy. And if there is increase or decrease in the nuclear charge, it can also affect the ionization energy of an atom. So one by one we will discuss about all these factors going to affect the ionization energy. So let's have a look. The first one is atomic radius. You must know that what does mean by atomic radius. It is the distance of nucleus of an atom and the outermost shell. For example, this is the nucleus of an atom and this is the second shell, for example. So the distance between the valence shell and the nuclei is known as atomic radii. It is denoted by R. So atomic radius can affect the ionization energy as well. When we move from top to bottom in the group, atomic size is going to increase from hydrogen. Next we have lithium. After we have sodium. Likewise, when we move from left to right, lithium, after we have beryllium. After beryllium, we have boron, is having two. Next, we have boron and then carbon. After carbon, we have nitrogen. And after nitrogen, we have oxygen. And after oxygen, we have fluorine. And after fluorine, we have neon. This is a simple sketch. This is the group 1A from top to bottom. It is the first period, this is the second, and it is the third one period. So when we move from top to bottom, as there is increase in the atomic size. When atomic size is going to increase, it means the valence shell is going away from the nucleus. When valence shell is going away from the nucleus, so there will be less pull of nucleus towards the electrons of the valence shell. So we have to provide less energy. It's mean when atomic size is going to increase, then there is decrease in the ionization energy. So it's mean atomic size is having inverse relation with the ionization energy. When there is increase in the atomic size, then the ionization energy is going to be decrease. This is the effect of atomic size. Next we have the nuclear charge. Nuclear charge is basically the charge on nucleus. It is a charge on nucleus, and the charge is positive. It is due to the protons present in the nucleus. How the nuclear charge will affect the ionization energy? When there is increase in the nuclear charge, when nuclear charge is going to increase, it means the nucleus now will pull the electrons, will pull the valence electrons or outermost electrons more tightly, more tightly. Then we have to provide more energy, more energy to remove the electron from it. It means there is the relation between nuclear charge. When we are going to increase the nuclear charge, then we have to provide more energy. It means increase in the nuclear charge will increase the ionization energy. So there is a direct relation between nuclear charge and the ionization energy. Next factor that affects the ionization energy is shielding effect. Now you must know that what does mean by the shielding effect. So shielding effect is the decrease in the force of attraction between the nucleus and the valence electrons due to the electrons present in the inner subshell. For example, this is the valence shell and it is having electron, and this is the nucleus. And when inner shells are going to increase, now these shells will decrease the or reduce the pull of nucleus to the valence shell. This reduction in the force of attraction between the nucleus and the valence electrons due to the electrons present in the inner subshells or inner shells. This reduction is known as shielding effect, as these shells are going to work like a shield between the valence shell and the nucleus. So this is known as shielding effect. So shielding effect shielding effect, there is a relation between shielding. When shielding effect is going to increase, it means the inner shells are going to increase and the outermost shell is going away from the nucleus. When it is going away from the nucleus, so there is a inverse relation between the shielding effect and ionization energy. When we increase the shielding effect, then ionization energy will be decreases. Shielding effect is having inverse relation between it, as shielding effect is going to increase from top to bottom, the shielding effect is going to increase, and in turn, according to the relation from top to bottom, the ionization energy is going to decrease. So next factor that is going to affect the ionization energy, it is the electronic configuration. So how does the electronic configuration of an atom affects the ionization energy of the atom? Electronic configuration is if the atoms have completely filled orbitals. There are two conditions: completely filled orbitals, or the second condition is half filled orbitals. Half filled orbitals. Ionization energy also depends upon the electronic configuration in a way. If atom is having completely filled orbital, then we need more ionization energy to remove the electron. But if an atom is having half filled orbital, then we need less energy to remove the electron from the valence shell or from the outermost shell. So its an atom is having completely filled orbital, then it is having more ionization energy, or it require more ionization energy to remove the electron. And if an atom is having half filled orbital, then we require less energy or low energy to remove the electron from the valence shell. So this is all about our today's lecture.